So in the previous video, we actually talked about the causal and non-causal system, if you still remember. Alright, or it's called causal, not causal. Alright, but anyway, we actually proved to you that uz equals to hold on a while. We proved to you that uz equals to hz and ez. Not proved to you, but rather than we start out from this thing, and eventually we derive using the z transform, etc., and we derive this thing, correct? So in this video, I'll derive, alright, using this thing, and back to this uz equals to hz ez. Alright, so therefore let's go. So if I have this equation, alright, I actually move it to here. Alright, so your uk, if I were to z transform your uk over here, and then z transform your ej and your hk minus j, which is all over here. So I'm actually z transforming this whole thing. Alright, if I were to somewhat shift it. Alright, so if I were to shift it like this, alright, then this is somewhat like a function like this. So you are z transforming this portion over here. Alright, so I can also shift it over here lah. Alright, but nonetheless, let's just continue and see how it goes. So I'm gonna z transform all this thing right now. Okay, so it's the same thing. So your uk, if you z transform, you have uz, correct? It's just, yeah, I've proved to you somewhere in other videos. Alright, so, but anyway, and then I can actually simply bring this zk inside. I bring this ej outside. Alright, so the summation point over here is this, and this is the thing over here. Okay, so I'm just simply shifting the ej over to the other side. You just compare this one and this one. Okay, are they the same? They are the same, right? I think you get what I mean. Alright, but anyway, so now I will let k minus j is equals to l. So I will let this thing over here to be equals to l. Okay, so if k minus j is equals to l, then my h will change to hl, right? So this is why over here is written as hl. But if it's k minus j equals to l, then this portion over here has to be also changed into something like this form. So this is minus k, so how can we do this? Alright, so I'll simply bring the l to the other side, and the k, maybe I should bring the other side. Anyway, maybe I should bring the k equals to l plus j. Okay, so k is equals to l plus j, which is over here, you see, k equals to l plus j. So because we are minus k, so it's minus l plus j. Alright, and from k equals to minus infinity to l is equals to minus infinity. Okay, so I'm actually switching the domains already, as you can see, right? Well, this thing over here I didn't change. I only switch this thing with this thing. Alright, k minus j equals to 1. I mean equals to l, sorry. Now, if I were to break out this thing, what I will have is hl, alright, z minus I multiply inside both of them. Okay, so I would have minus l, z minus j. Alright. So in other words, this thing over here, if I were to shift this thing over at this side, okay, do you find it familiar? This thing that I've just written is exactly this one. You can compare your hl, your z minus l, g minus j, you see? So what I'm doing is simply to also, in another sense, somewhat prove to you that if example you have zuk, alright, not zuk, but rather than zuk plus 1, for example, alright, we can somewhat say that is zuz. Alright, we somewhat prove to you already. Alright, this is z minus 1. Alright, same thing. Over here this is k minus j. Over here is k minus 1. If I have a k minus j, then I will have what? I will have z minus j, right? Z minus j uz. Okay? So, yeah, I just want to prove to you lah. Later on you'll get to see that it's in fact also what I have written over here. But anyway, so this thing over here, I have proved to you that is equals to this. Next, I'll just simply shift this. Alright, I'm gonna shift this to the other side. Alright, sorry a while. So I'll shift this to this side. Okay. Next, if you find this familiar, this is a z transform of l, right? But it's still in the z transform. Okay, because instead of k it's l now. Okay. So if you z transform this h over here, what you have is hz. This is hz, and this thing over here becomes your another z transform of e, right? At first your summation, if you take a look, at first your summation is just like this, right? And then I use this one, k minus j equals to l, and I'll have, and I just sub it in over here. Eventually I'll have this, right? And then next, alright, then I'll break it. What am I talking? At first I have this thing, okay? Then I z transform the uk, which is this one, okay? And then I z transform this whole thing, okay? And I'll have, and then I shift the z minus k from just now, if I were to take it. Alright, this definition, if I were to bring it out, alright, this is the z transform of this whole thing. And then next step is I bring this to the other side, right? I bring this here, and then next, alright, I actually shift this ej over here. I shift this z minus k over the other side. So in fact I don't need to shift the z minus k, but anyway, so I will shift. So at first, no, I'll shift this thing out, and I'll shift this thing in, right? So this is what is being looked like over here. Alright, this is this. Alright, so therefore the next step I do is to actually use the k minus j is equals to l. Alright, so I do this thing such that it becomes like this, correct? And I didn't touch this ej. This ej is still here, you see. Alright, so this portion over here is still aren't any z transform yet. It's something like a summation only. Alright, the z transform by right should be something like this, your function, alright, z minus k, alright, something like this. So your summation from k equals to infinity, minus infinity to infinity, and z minus k at the back. Do you see any z minus k, j, z minus j at the back? Because this is j, so we have a j over here. But anyway, so in other words, if you have a, instead of k we have j, then this thing will become z minus j. It's the same thing, it's still z transform lah. So over here, do you see any z minus j? Don't have ma, right? So therefore our purpose over at this side is to spawn out a z minus j for this dude over here. Alright, so therefore, alright, the next step over here, after I sub in my k minus j equals to 1, I'll have this thing, and then I break it down into here. Alright, and over here you can see that there is a z minus j already. Alright, and then I shift it to this side. You see, so this part over here is in terms of a j z transform. Okay, over here, so j and l, so this part is l, this part is j, but don't care about what k, j, l, whatever, right? As long as you have this thing, these two things, you're actually z transforming your whatever function you are. Don't care about this subscript. This is just indicating some alphabet, that's all, nothing much. Alright, so what you're looking at must be these two, you see. So these two are the operations of a z transform. So over here, if you do this, you have ez. Over here, if you do this, you have hz. Okay, so don't care whether is it k or what. Alright, but in this case it's j and l, but it's still something like a k. If you don't feel it like a very familiar to you, you should adapt to this, right? Because ek, if you, for example, ek, if I want to z transform this ek, I'll have summation z minus k. Alright, so if I have ej, for example, then same thing, I'll just summation from j equals to minus infinity, and then z minus j is just a subscript only, nothing much. It's the same process of z transforming, that's all. It's just a different alphabetic name. Alright, I can also have a e smiley face. Alright, summation from smiley face is equals to minus infinity, and then z minus smiley face, that's all. It's the same thing, I can just anyhow write, but it's still the meaning of z transform, that's all. Okay, and therefore I'll just leave you to this this concept. Alright, so see you.